Welcome to Study Loop.
We have a circular aperture and it produces a diffraction pattern. For the radius of the first dark fringe corresponds to the angle at which the intensity falls to zero. So we know that the wavelength is 562 nanometers. Let's say the diameter of the aperture is d and the distance is x. We know the equation is d sine theta is equal to lambda, which means sine theta is equal to lambda by d. Now sine theta in this case is simply sine theta is almost theta because the angles are very small, and hence r, which is equal to r by x. So r by x is equal to lambda by d. So we have x and r. Let me write down the values in meters and centimeters. So to find d, we simply use d is equal to lambda times x by r. So let's do it for the first case. Lambda is 562 times 10 power minus 9 times x by r is 1 by 5.6 into 10 power minus 2, which turns out to be 10.04 into 10 power minus 6 meters, which is 10.04 micrometers. Similarly, we can do the calculation for the rest of them, and you get answers 9.919 micrometers, 9.689 micrometers, and 9.69649 micrometers. We simply take the average value and we get it to be 9.9 into 10 power minus 6, which is 9.9 micrometers. Now, for part B, we want to find out the radius of the second and third order diffraction minima for m is equal to 1. So, I'm sorry, for x is equal to 1. So we know that r is equal to m lambda x by d, and so x is 1, so simply r is m lambda by d. So r2 corresponds to 2 times lambda by d, which turns out to be 0.1135 meters, which is 11.4 centimeters after rounding up. And r3, the radius of the third diffraction fringe, the dark fringe, corresponds to 3 lambda by d, which is 17 centimeters.